Hello, everybody. This is Pete from PA Labs, and today is not going to be a video with lots of cool graphics and eye candy and that sort of thing, but it's for those who are entertaining the thought of laying their hands on the source code and figuring out how this game engine works and how do we keep track of where units are and where cities are and who owns them and all of that sort of thing, and do it on a phenomenally lightning speed scale. Okay, and this is this map grid array is what I'm going to walk you through how it works and why. And this is actually, I'm implementing this now in the game designer, which has taken quite a while because I'm modifying it crazily. But it's also going to be in the game player and in the server. Okay, the server really is where this is going to shine, and here too. Because I kind of ran into a point yesterday, and you saw it in the video, where you click an existing cell and it's got a city in it, or it's got a facility, or maybe it's got 2 units, maybe it's got a city with 3 fighter wings in it, 3 squadrons of fighters, and you click the cell and you're given a menu that says, hey, you want to modify the city or fighter wing 1, 2, or 3? What do you want to play with? And so how does the system know, first off, what is in that specific cell without having to go back and go through all of the arrays of the map engine and search for the row and column? So I have to spin all the different records of cities and units, and it becomes a huge cumbersome search, okay? Especially when you start looking at units that are carrying units, and the permutations of that is it gets ugly and eventually gets very slow. So I came up with an idea when I was writing this in Windows that is, it alleviates every single piece of that, but it's got a couple caveats. You have to remember to religiously use it in your code, okay? Now, what I have is a map grid structure, and I have a map grid array, which is a string array of 100 by 100. Now, 100 by 100 is the maximum size that maps can be. 100 squares, 100 hexes by 100 hexes. So you don't, if you redimension arrays, you can only change the second array element. You can't change the first, so I can't create it uniquely by individual map. So I just build one that covers all maps. Now, we have a structure here of map grid. Map grid carries, and this is what's changing pretty radically. So we have a city for the cities. A city can be on a row and column. So this is going to be tantamount to row, and this 100 represents columns. So rows and columns. So in any one cell, any or all of these can exist, all right? You can have a city. Well, actually, you can have a city or you can have a facility. These are either ors, all right? So we keep track of what is the city ID, what is the index in the array for this specific city, who's the map player who owns it, and I believe I'm going to convert this to be the game player. So we have a map player and we have a game player. So in a game, if you are doing a single map game, then these are exactly the same thing. The map player is the game player. So if you have a multi um, campaign game where you have multiple maps, you may represent pirates in one, the British Armada in another, and the Spaniards in a third, okay, or something. It dynamically changes by map, but then you might be the hero of the game hero as the player who controls all of these people across all of these maps. And then within each map, a player controls multiple nations. So opponent here is actually, this is going to convert to be a game player. So for the moment, look at it that way. So we then have, okay, here's our city information. Then we have the possibility of having a facility, not a city. So we have a facility ID, index type, a map player, and a game player. And then in any one cell, or this is going to be kind of bizarre, I'm going to build a game configuration element so you can control, do you want people to have 3 units in a cell? Do you want them to be forced only to have 2 units in a cell, which is really the ritualistic standard is 2 units to a cell. A unit can be either infantry or armor or artillery. You don't mix. So in the game currently, you can have 3 Air Force squadrons in a city, landed at an airport in a city, or landed on a carrier, or landed on a field airstrip somewhere in a field somewhere, right? So you can have up to 3 air wings in each of these. So you have to have 3 units that are possible to be in a cell. So now it gets a little confusing because it's theoretically possible to have a airstrip that has 3 squadrons in it, and there are 3 or 2 armored units also on the airfield hex. So theoretically you can have 5, or if your game you can stack 3, you could have 6 units plus a city plus a facility in any one hex, which gets a bit crazy. So what we do is first off, you would say, hey, you've got a facility with 3 units. Do you want to modify that? Or do you want to modify your 2 or 3 armored or infantry land units that are sitting on top? So you'd have one set of grids for that. And then when you open the facility screen of the airfield, you then have the 3 units that exist inside the airfield that you can now play with. Okay? So this is the structure that we play with. Now, if you notice, this MapGridArray is a string. It's not of type MapGrid. All right, because that gets in my head a bit crazy. So what I'm doing is I have a extract and a serialize MapGridArray. All right. So actually, I guess that ought to be MapGrid. So we're playing with the array, but we'll call this MapGrid for right now. Maybe I'll drop the array thing off of there. Like I said, I'm building this today, and it's a very involved piece of code. So here, what you do is you get a JSON string, and you get you pass this extract the JSON string and an object of type MapGrid, this structure. All right. Now, what this does is take the JSON string and loads the structure. Okay. So then all of a sudden you have it as your nice little structure element. So you can do map grid or grid item dot city or slash city ID and that sort of thing. And we have a serialize that takes a grid item of type map grid and converts it to a JSON string. So what we do is there's a create step that will go through one time as you load a map, and it will load up every single city, every single facility, every single game unit into this map grid array. And it's indexed in here by row and column. So anywhere in the grid that you select a cell, we can then go up against the map grid array by row and column and retrieve the serialized string of the map grid of everything that's in that column. Now, it's important that here we're keeping track of the index actually in the arrays or in the lists where the city exists. Okay, cities cannot be destroyed. They can be destroyed, but they still exist as a destroyed city. Facilities cannot be destroyed or removed from the game. They are just destroyed, but they're still there because they can be repaired. Units, on the other hand, can be destroyed. So if I destroy this unit and it goes away, this index, everybody's index that follows that in the list will now change because this guy, they move up. All right. So when we destroy a unit, we have to rebuild the unit piece of the array. Okay, the whole map grid array. So that's a thing that we gotta, when a unit dies as part of the ending combat sequence, to kill the unit, mark it as dead, delete it out of the data, out of the list, the map list of units, and then the next step is to rebuild the map grid array for units. All right, and that way we update all of those indexes and kind of refresh what everybody's called. And then, so what we have is now you have this extract and you have a serialized map grid. So those are how you interact with the map grid array. Now, below this, we have the step that says, okay, build the map grid array. This guy comes in and is going to spin the work map unit collections and the cities and all of that. So this is the guy that loads the entire array with a single call. It runs exceedingly fast, less than a half second to completely rebuild this array. So it's not like it's a big deal. So now we have what's called the gets. So we can get a position for an owner. We can get a unit count for a cell, how many units are in the cell. We can get a unit position. We can get the, this will end up changing to be the map or the game, what is it? The game player. All right. We can move a unit from to another cell, all right, just within a single call. So as units are moved, you also have to call this to move it in the array so everything stays fine. So anytime you can query this array, you then have every piece of information of what is in that particular cell. Now we have add a grid unit, delete a grid unit. That would need to be called when you kill a unit. Adding a unit is when, we're on the resupply and you create a new unit on the field that comes in. Maybe they come off a ship and then join us in a battlefield kind of scenario. Or that sort of thing. Also, you will have the ability to take a unit and split it into 2 units. So you'd have 2 units of half size versus 1 unit of full size. and then that theoretically generates a brand new unit and changes the existing unit. Likewise, you can take two units and merge them together on the player, and then that eliminates a unit. So remember all of these things that have to take place. So these are just the functions that exist to, count the number of city, or get city count. That one doesn't make any sense. Maybe it's actually spinning the whole thing. No, looking there. Extract map grid. Oh, this is initializing it. So, okay. So he's seeing if there's a city in a particular cell. Okay, so get the player in a city, the game player. Does he have something in the cell? You can add and delete cities. Not that really you can delete a city. I don't think that's actually, this is just, I've built it just because if you add it, maybe you need to delete it. So we can get counts of all kinds of things. So that is what the MapGridArray code sheet is all about. So then when we're over here, let's go ahead. You're not called. So let's go ahead. I think I can run this. And so we come out here to our game. Let's go ahead and create a city. Let's put London here, so we can say that this is London, and then he's got a population of say 5 million, and he is owned by allies, and he is England. Yes, we're going to put in a port. He can build units. We can say build everything. What the heck? And now let's come over here to units in the city. We can take a bomber and add the bomber. Let me get rid of all this debug stuff. We can add a second bomber, and we can add a fighter. So we have 3 fighter wings in the city. So now, whoops. All right, get this out of my way. So we can hit save, and I thought I had that fixed. Somehow I got rid of the first stripe here. He's supposed to have 3 stripes, red stripes on him, to tell you that there are 3 wings in that particular city. So now when I click here, we can edit the city. So how do I know what city that is without having to go back to the game map and look at every single city that is configured and look at it and say, hey, does your row match this row that he clicked, and does cell map the column map the column? We found one match. Great, here you go. And then I have to turn around and go all the way through all the units 3 different times to get all of one and pick up all 3 units that are also labeled as in that cell. Okay, so that's how it's going to come up with edit the city. Is all he's going to do is do one call against that map grid array, the map array, and say, hey, what's in this cell? He'll come back and say, oh, there's a city there, and we can then pull up the city directly by its index, and then populate the screen and pop the screen in a matter of like 2 or 3 sentences of code, and instantaneously you have the screen here. So that is how the indexing works across this entire game structure. Okay, that map grid array, the server keeps his own list of what is in the entire game, and the player is going to basically query the server to say, hey, I want to move this unit from this cell to this cell, and it will ask the server will look those cells up and say, yep, you can do that, here you go, and then you move it. All right, if you want to attack from one cell to another cell, it queries the server to say, hey, get me all the units in this cell, get me all the units in the attacking cell, the defending cell, and let's bring up the combat screen and resolve the combat. Okay, so that is a very fast, very important built-in piece of this entire gaming structure. And if you're gonna play with the code and take this apart and see how it works, this be sure to give this MapGridArray a thorough search and understanding, and watch the code, because there'll be lots of references that says, hey, MapGridArray do this, MapGridArray do that, that sort of thing, because everything kind of pegs against this, because it converts from going through a list to physically just a index lookup of grid column. Bam, here I have it. The converting of string to JSON, the JSON string to loading a object here, a structure, is literally instantaneous. So that absolutely costs nothing to do. Same with the serialization. The extraction and the serialization is an instantaneous sort of thing. So all we have is this one array in memory that handles all of these things for us. So I know today's video has been pretty technical, but that's how it works. That's how this whole structure works. And I'm sure I'll touch on this in a future video. So we will probably, when I'm doing the server, I'll come back to this and say, hey, do you remember that video I gave you on the map grids? Well, here it is in working order. Here's how the game asks the server about what he can do. So that is how the client-server aspect work. The client is kind of a stupid client. He asks the server for information of everything, and the server answers back. So that communication across a local network is literally instantaneous. So it's very, very fast, and it's very efficient. And not having to spin arrays, being able to jump straight to an index is pretty phenomenal. So anyhow, that concludes this video, and as always, I want to thank you all very much for watching.